discuss about vector addition in this lecture. Let's say I have a particle and it is located at point O. I'd like to move this particle to, let's say, point A. Well, what this means is my particle undergoes a displacement. It was at O, I'm moving it to point A, and I'd like to express that displacement by a vector, which I will call F1. F1 is a vector, which you may have learned from physics. A vector has magnitude and it has direction. The magnitude of F1 is the distance the particle moves from O to A, or how far the particle moves from point O to point A, and I can clearly measure that distance. And not only that, but F1 also has direction, and the direction of F1 indicates the sense of direction of the displacement, and I'd like to express that sense of direction by the dotted line. Let's say I'd like to move my particle to another point. Let's say I'd like to move it to point B. And so the particle is at A, I'm moving the particle to point B. What this means is the particle undergoes a second displacement, and I'd like to express that second displacement by a vector, which I will call F2. And just like F1, F2 has magnitude, which is how far the particle moves from A to B. Again, I can clearly measure that distance. And it has a sense of direction. And the sense of direction of the displacement from A to B, I'd like to express it in terms of the second dotted line. Well, according to vector addition, we are able to replace F1 and F2 with an equivalent vector called the resultant vector. The initial position of the particle was at point O. Its final position is now at point B. So therefore, if I were to replace F1 and F2 with an equivalent vector, I'd have to start that vector at O and I'd have to end that vector at B. And so this pink vector would be my resultant vector that replaces F1 and F2. If I were to express this mathematically, I would say F1 vector plus F2 vector is equal to the resultant vector. And this equation clearly expresses what we did with our particle. We first moved the particle from O to A, and we gave that displacement a name, vector F1. And then we moved it from A to B, and we gave that second displacement a name, vector F2. And we looked at its initial position, which was at point O. It underwent two displacements. Its final position is now at point B. And if I were to replace F1 and F2 with an equivalent vector, that vector would have to start at O and it'd have to end at B. I'd like you to notice that it does not make any difference whether you give the particle first the displacement F1 and then F2, or vice versa, F2 first and then F1. Notice that this vector is equivalent to F1 because it has the same magnitude as F1 and it has the same sense of direction. And similarly, this vector, it is parallel to F2 because it has the same magnitude as F2 and it has the same sense of direction. A very important point in vector addition is that it does not make any difference whether you give the particle first the displacement F2 and then F1, or vice versa, F1 first and then F2. Both will yield the same resultant vector.